Hello everyone, welcome to PDV Lidex Education, the educational biome of pure excellence and extremely high quality. So guys, we are going to do this exercise together. It is an extract from Cameroon GCE June 2016. So it says that give the products of the following conversions. So the first, we have a halogen, right? When you are answering such questions, the first thing is that you try to identify the compounds involved. Then you look at the reagents, right? Here we have not been given the reaction conditions. What is most important are the reagents. But however, we shall put together the reaction conditions so that when you find it in other questions, you'll be able to answer properly. Okay, so when you have a halogen attached on a hydrocarbon chain, right, we call that compound a halogenoalkane. Halogenoalkanes have the general formula Rx, right? They have the general expression Rx, where X is a halogen. So here we have a halogenoalkane, and the halogenoalkane is reacted with alcoholic alkali. The reaction takes place under reflux. So the reaction condition here is reflux, right? It takes place under reflux because halogenoalkanes are very volatile. Then secondly, when a halogenoalkane reacts with alcoholic alkali, it produces an alkene. If it reacts with an aqueous alkali, it produces an alcohol, right? Halogenoalkanes undergo elimination reaction when they react with alcoholic alkali. So how do we eliminate? We are going to remove the the halogen together with one hydrogen on the beta carbon. Here we have the alpha carbon, which is the carbon that bears the functional group or bears the halogen. And here is a beta carbon. This is also a beta carbon. So we shall remove the halogen alongside one of the hydrogen on the beta carbon, which has more hydrogen. The one has more hydrogen. So our product, so we shall remove bromine and one hydrogen from here. So we are going to have the product as, the product will be CH3. Here we have CH. We remove bromine and one hydrogen from here. So we have a double bond. And then we are left with CH and CH3. So that is the product of the reaction, and the mechanism is elimination. So the product is called butene, right? Butene, and the product exhibits geometric or cis-trans isomerism. Okay, the next compound is nitrobenzene, right? Nitrobenzene reacts with tin in concentrated HCl. This reaction is a special reaction, and the mechanism, it takes place by reduction. The reaction is called reduction. So here we are going to reduce nitrobenzene. In place of tin, we can also use iron as our reducing agent. So the reaction condition is heat, right? If you ask for the reaction condition, you are going to heat. Please take care of this reaction. It comes a lot at the GCE. So reduction of nitrobenzene using tin and concentrated HCl under heating, it produces an amine, right? Phenylamine or aniline. So how do we write the product? We are just going to replace the oxygen with nitrogen, with two hydrogen, sorry. So our product is going to be this. We replace the oxygen with two hydrogen. So that's our product. The product is called phenylamine or aniline, right? That is a compound formed when we reduce nitrobenzene under using tin and concentrated HCl under heating. The reaction takes place by reduction. If you ask to name the reaction, you say that it is a reduction reaction. The next one, we have an acid chloride, right? When you have a carboxylic acid group, right, with a chlorine derivative, you call the compound an acid chloride. Compound that have RCOCl, they are called acid chlorides. So acid chloride react with ammonia, right? They react with ammonia to form amides. Amides are compounds that have the structure RCONH2, right? RCONH2. So RCONH2. So the compound, the product will be CH3, CH2, CO. We replace the chlorine by NH2, right? Then the other hydrogen from ammonia will combine with the chloride to form hydrogen chloride. So another product formed there is hydrogen chloride. But generally, when you're asked to write products of reactions, right, in organic chemistry, you are writing the major product, the most important product, and that is the amide. So this reaction, generally, acid chlorides are very reactive. So the reaction generally will take place at room temperature. So the condition is room temperature, or 20 degrees Celsius, or around 20 degrees Celsius. Okay. So, and the mechanism, right? Yeah, you notice that the only change is that the chlorine is replaced by ammonia before losing one hydrogen. So the mechanism is nucleophilic substitution, because ammonia is a nucleophile. Ammonia has lone pairs. So the ammonia replaces chlorine, and we can call it nucleophilic substitution. Then here we have an alcohol, and of course a secondary alcohol, because the hydroxy group is at carbon number 2. At carbon number 2. So here we have an alcohol, a secondary alcohol. The alcohol is reacted with what? Acidified potassium dichromate. Whenever you see acidified potassium dichromate, you think about oxidation, right? Because this one is a special oxidizing agent, acidified potassium dichromate alongside acidified potassium permanganate. They are generally used in organic chemistry to perform oxidation reactions. And about the alcohol, what do we know? Primary alcohols oxidize to give aldehydes, while secondary alcohols oxidize to give ketones. And lastly, tertiary alcohols are not oxidizable because they lack alpha hydrogen on their alpha carbon. So here we have a secondary alcohol. It is going to undergo oxidation to produce a ketone. So how do we write the structure of the ketone? The ketone structure will be written by removing 2 hydrogen, right? 2 hydrogen from this compound. We remove the hydrogen on the alpha carbon. This is the alpha carbon. The one that bears the functional group OH is the alpha carbon. So this is the alpha carbon. So we shall remove this hydrogen alongside this hydrogen on the hydroxy group. When we do that, our product is going to be, so here we shall have CH3, after we have CH2, after we have C, we are left with O, and then lastly we have CH3. So that is a product. That compound is a ketone, and the name is 1, 2, 3, 4. That is butanone, right? That is butanone, right? Or butanone, sorry, right? Because the carbonyl group is at carbon number 2. So this is a carbonyl carbon. So we call this compound butanone, right? And here we have what? We have butanol, right? This butanol. Butanol clearly shows an isomerism that we call optical isomerism, because the alpha carbon here is asymmetrical. If you observe very well, the alpha carbon has 4 different groups around it, right? This is one group, this one is one group, then the hydrogen is another group, the OH is another group, and the CH3 is another group. So butanol shows optical isomerism. Okay, now we did not name this compound. This compound here we have, this is 1, 2, 3. So here we have propanoyl chloride, and here we have propanamide, right? This is propanamide, yes, and amide. Now lastly, here we have this is an aromatic derivative, because here we have a benzene ring, and then we have an ethyl group on the benzene ring. So yeah, we can call this compound phenylethane, or you can also call it this group. When you have the benzene ring together with CH2, you call that one a benzyl. So this is benzyl methane, or phenylethane. Yes, phenylethane. Yes, or ethyl benzene. Yeah, properly. Yes, we call it ethyl benzene. Okay, yeah, that's ethyl benzene, because here we have an ethyl group and then we have a benzene. So you can call it ethyl benzene, or you call it phenylethane. Yes, or you call it benzyl methane. Yes, benzyl methane. If I consider this group as a side chain, it will be called benzyl methane. So those are the different ways in which you can name this compound. Now what do we do? Okay, please here. Whenever you carry out oxidation with permanganate, the condition is that you should simply undergo warming. Alright, this experiment you see a lot in the practicals. Now we come here. Benzyl methane or phenylethane or ethyl benzene, right, is oxidized by alkaline potassium permanganate. This reaction is also called oxidation, and this reaction converts any alkyl group on the aromatic side chain into a carboxylate. Any alkyl group on the aromatic side chain, right, this reagent oxidizes it into a carboxylate or into benzene carboxylic acid. So this group here will be changed into the carboxylate group. So our product is going to be this. This is our product, COOH, which is benzoic acid, right? So whenever you have this reagent, alkaline potassium permanganate, and you have an aromatic ring with an alkyl derivative, just know that the alkyl derivative will be converted into a carboxylate. The process is called oxidation. Yes, and the condition for that is that the alpha carbon, right, the carbon atom that bears the alkyl group to the benzene ring must possess at least one hydrogen. So as long as there's at least one hydrogen on this carbon, this group will be oxidized to a carboxylate. So guys, in that case, if you have understood, I would like you to answer this question as, right, to give us the product of this reaction. Give us the product of this reaction. Yes. So what is a product form, right, when this compound is reacted with this oxidizing agent? You put the answers in the comment section and I will congratulate you for following up attentively. If not, please ask your questions and follow up with PTV Lidex Education. Many more lessons are going to come up, and as well again, we invite you to our various centers, Yaoundé or in Douala. Join us and enjoy the beauty of PTV Lidex Education. Have a nice time and may God bless you. Ciao.